In today's video, I would like to introduce a very nice problem. Our goal, we are going to find the last digit of this number. Okay, we have 127 to the 599 to the 232, okay, as an exponent. So in fact, this is very large number. We don't know what's the last two digit. So in order to find the last two digit of this number, there is a technique for that. The most useful and important tool that I'm going to use here is called Euler theorem. Euler theorem is written on this form: if GCD of the number b as a base to the n equals 1, okay, then b to the phi of n is a congruent to 1 mod n. So for example, if you have a number 129, is written on this form 100 plus 29, okay. If you've been asked to find last two digit for this number, which is 29 as a remainder, so the most important thing here, we are going to find the remainder of this number, okay. This one is congruent to 29 mod 100. So I'm going to use the same thing here. I'm going to reduce the whole number to the mod 100, okay, by using this tool, Euler theorem. So if I'm going to calculate 3 to the 4 is a congruent to 1 mod 10, okay. In order to prove this one, I'm going easily to apply this tool as a Euler theorem. So I'm going to find, let's take 3 as a base, 3 to the phi of 10, okay. So there is two ways to calculate this one. I'm going to list all the numbers 1 through 10. I'm going to take just the number which relatively prime to 3, okay. All the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You are going to find GCD first. GCD of this number, the base which is 3 and n is 10 equals 1. If you don't have this condition, you are not allowed to use this one, okay. You have to have first this condition. 2, it will be crossed out because GCD of 10 and 10 is 2, and number 4 because GCD of this one is number 2. Number 6, their GCD is number 2. 8, the same thing, number 2, okay. Number 10, number 5 as well. How many numbers are relatively primes to number 10? I have 1, 2, I have 3, 4. So this is the size of this one, number 4. I'm going to calculate this one in different way by using the Euler theorem. So the general formula of this one, phi of n equals n is multiplied by 1 minus 1 over p1 factor 1 minus 1 over p2 and all the way down to 1 minus 1 over pk, okay. So for our example, phi of 10, number n is 10, factor. Now I'm going to look for the prime factors for number 10. We have only two prime factors, number 2 and number 5, because 10 is divided by 2 is giving us 5, 10 is divided by 5 is giving us 2. So we'll have 1 over 2 and is multiplied by 1 minus 1 over 2 factor 1 minus 1 over 5. The most important thing, you have to have the prime numbers as divisors of number 10. We have here only 2 and 5. So if I'm going to calculate this one, I have 10 is multiplied 1 minus 1 over 2, which is half. This 5 is multiplied by 1 minus 1 over 5 is giving us 4 over 5. By cancelling out number 2 from here, I will get 2 here. I will get 2 over 5. That's mean 2 over 5 is multiplied by 10 is giving us 4. So I found the same result, okay. Phi of 10 is number 4. This one is congruent 3 to the 4. I will get 3 to the 4th. 3 to the 4th is 81. 81 is the same as 1 mod 10 because we have one more than area, okay. I'm going to prove this one with different methods. So I have 3 is a congruent to 3 mod 10. I'm going to raise number 2 as a power on both sides. I will have 3 square is a congruent to 9 mod 10. 9 is a congruent to -1 mod 10. I'm using the negative numbers because you have 9 is 1 less than 10. So I'm going to raise both sides. I'm going to raise number 2 as a power on both sides. I will get 3 to the 4th is a congruent to 1 mod 10. So I found the same result. Okay, now I'm going to raise this board and start with our problem. Before you apply this theorem, you have to make sure the GCD of B and N equal to 1. Okay, so we have phi of N. I'm going to calculate a phi of N of this one. Phi of I'm going to reduce the whole thing to mod 100. Phi of 100 equals 100 is multiplied the prime factors for 100. We have only 2 prime factors. We have number 2 and number 5. So we'll have 1 minus 1 over 2 factor 1 minus 1 over 5 is giving us 100. This one is giving us half. This one is giving us 4 over 5. If you calculate this one, you find 40. Okay, going on with this problem, I have 2 levels here. First level, I'm going to use this formula. I'm going to use this formula on 2 levels. The first level, I have phi of 100 and we'll calculate the phi of 40. Okay, so if I have B as a base, phi of 100, then I'm going to take this one as a base as well to calculate phi of 40. This is the same formula that I'm going to apply here. Okay, that's what happened. I'm using 2 levels in this formula. So the whole thing will be reduced to the mod 100. Okay, this one will be reduced to mod 40. This one I don't know yet. I have to calculate phi of 40 first. So phi of 40, I'm going to use the same formula. 40 is multiplied by 1 minus 1 over. Now I'm going to find out the prime factors of this 40. I have 2 and 5 because 40 is divided by 2 is giving us 20. 40 is divided by 5 is giving us 8. So we'll have 1 over 2 here, factor 1 minus 1 over 5. I will have the same thing here. 40 is multiplied by half is multiplied by 4 over 5. So I will get 16 here. Okay, so that's mean this one will be reduced to mod 16. Okay, now I'm going to work on our numbers. Now I'm going to check 232 first. 232 equals 16 is multiplied by 14 plus number 8. Okay, so when it equals 16 is multiplied by 14 plus number 8. This one is a congruent. If I'm going to reduce this one to mod 16, I will have 8. It's congruent to 8 mod 16. So we'll have here it's congruent to 8 mod 16. Okay, so I'm going to check the second one. 599. 599 equals the 40 because we have mod 40 here is multiplied by 14 plus 39 is a congruent to 39 mod 40. Okay, I'm going to use the negative numbers here. Is a congruent to minus 1 mod 40. 39 is 1 less 40. Okay, I'm going to check with 127. 127 equals 100 is multiplied by 1 plus 27 is a congruent to 27 mod 100. Okay, now I'm going to raise this one and replace all this information here. Okay, 127, 599 will be replaced with minus 1 to the 8. Okay, I'm just putting just the remainder because the most important thing is a remainder. Okay, so I'm going to use the trick here. 8 equals 2 fourth. Okay, this one is a congruent to 127 minus 1 square to the 4th. Okay, minus 1 square is giving us 1. I have 127 is 1 to the 4th which is 127. This 127 is a congruent to 27 mod 100. Okay, this is the last 2 digits. Now we have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.